Okay, this is one of your second to last reviews for the year. Let's make it a good one. Alright, so I'll try to be as thorough as I can. First question. Volume of a rectangular prism is 165. So you know what? Have your calculator handy because you're going to be using a calculator on Monday, so might as well get some practice, right? It's a volume problem, so to deal with volume problems, we're going to use volume equals big B times H. And let me just put out. So what do we know? Well, actually, before I can somewhat here pick a space. Volume equals big B times H. And big B is the area of the base. Okay, so in this case, it's a rectangular prism. So if you have the rectangular prism, the area of the base of the rectangular prism is a rectangle. So I know that the volume is 165, so I'm going to change this to 165. It's given to me. They tell me that the base area is 22, and I'm missing the height. So how do we find the height? Well, we're looking for a number that multiplied by 22 gives us 165. So you can do 165 divided by 22, all right, to find the h. So I'm going to actually just 165 divided by 22. It's going to give us our height. And 165 divided by 22 equals 7.5. And the actual unit is going to be 7.5 inches, okay, because that's going to give us the height, and height is measured just in inches, okay, not inches squared, not inches cubed, it's the height, okay. Name the 3D shape that each net can make. So if I fold this, okay, so imagine that this was peeled, and I fold it, and I bring this way, and actually peel this way, and peel this, unpeel it, yeah, actually fold it, I guess. It's going to fold inwards, right? And what you're going to get, okay, it's going to be a pyramid, right? So because all these 4 points is going to connect on top. I don't know how to draw a pyramid. Maybe like this. Yep. There you go. And they're all going to join on top here. And that's going to create a pyramid. And then what type of pyramid is this? It's going to be a square pyramid. Okay. This pyramid is actually, we classify it based on its base. So the base here, the bottom here is a square, as you can tell from this horrible picture that I just drew. Okay. This over here is going to be a cone. Do I know how to draw a cone? Maybe something like this. There you go, a cone. Alright, so if you fold this paper, fold it around, it's going to create this, think of an ice cream cone. Okay, and this cylinder is going to be that part right there. Okay, so this is a cone. Did I say cylinder? I meant to say circle. Here, this one, if you notice, okay, they're all squares. So the only shape this can make, if you fold, right? Fold this side, fold this side. It's going to create, excuse me, a nice little cube where all the faces are squares. This one is going to be, can I draw this? It's going to be, well, no, definitely not that. Let's try to draw this better. Like this, like this, like this. And it's going to go like that, out like that, out like that. Well, everything's going to go out that way. And on that side, you're going to have the other one, this bottom part, which is also going to be a pentagon. Somewhat like that. Right, so you got the idea, right? So it's going to be a pentagon on this side, pentagon on this side, and these faces over here, they're all rectangles. This is, so it makes it a prism, right? So this is going to be a pentagonal, is that a word? Pentagonal prism, okay? 3. What's the distance from point -4 and 2 and point J at -2? So actually, you know what? I should rather do this without this and just sort of. So if you have on the test, if you don't have this grid, create something like this: x-axis, y-axis, and let's talk about this point right here. This point right here says go -4, 4 spaces to the left, 1, 2, 3, 4, and then go 2 flights up, 1, 2, 1, 2. So that's where we are right here. So this is -4 and 2. Okay, it's 4 spaces to the left of the y-axis and 2 floors up. The letter J would be 1, 2, 3, 4, 5, 6, 7, 8, 9 spaces to the right in this case, and 1, 2, 2 floors up. So that would be 9 and 2. To find the distance between these 2 points, well, you can obviously count, go like this: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, and know that the distance is 13 by counting 1. Each step that you take to go from one point to the other, or you can find out that this point right here is how many spaces from this y-axis. 1, 2, 3, 4. So this particular distance right here is 4 steps, right, from the y-axis. Meanwhile, this guy is 9 steps away. So it's 1, 2, 3, 4, 5, 6, 7, 8, 9 steps away from the 9-axis, so for the y-axis. So this is 9. So knowing these two, I can just add these two and know that the total distance, because this is 4, this is 9, would give us 13. Okay. I feel like I'm doing this very fast. Hang on a second. I will pause. Pause. Okay, we're back. Box is 5.5 inches wide, 3 3/4 inches long, and 6.5 inches tall. All right, so what I want to do is just quickly write that this is my width, this is my length, and this is my height. Surface area, again, so there's 2 ways of doing it. I'm not going to do it the long way, so you can draw a prism here. All right, and you know that a rectangular prism has 6 faces, so you can actually draw all 6 faces. Okay, top, bottom, left, right, front, back, right, and find the area of each of these rectangles. Okay, and then add them all up, which is how we started the unit. Okay, or now that you know that, we can just simply do this, right? LH, LW plus 2 plus WH. So LH, okay, length and width. This represents left and right. Length. Sorry. Ooh, I made a mistake here. So that should have been LH. LH represents the front. This represents the top. This represents left and right. So front, if I know if there's a front, there's a back, and they are the same measurement. If there's a top, there's a bottom, and they are the same measurements. And if there's a left, there's a right, and they are the same measurement. That's why I'm multiplying by 2. Okay, so substitute. We're going to go 2 times the length is, did I just erase everything? Where's the length? This is the length, this is the height, and this is the width. So the length is 2 times 3 3/4 times h, which is 6.5. The second group is 2 times the length again, which is 3 3/4, times the width, which is 5.5. And the last group here is 2 times the width, which is 5.5, times the height, which is 6.5. Okay, I'm doing it like this because I don't have a big line, you know, a big straight line. So find the product of each of these 3 parts, and I'm going to use decimals because my calculator doesn't use fractions. So 2 times, we're going to multiply that by 3.75 times 6.5, because that's the decimal equivalent, and we're going to write that this ends up being 48.75. Second group, it's 2 times 3.75 times 5.5, and that's going to give us 41.25. And the third group, the left and the right, is going to be 2 times 5.5 times 6.5. And if my calculations are correct, I'm like 71.5. Okay, so now we have to add all three. So we get plus 41.25 plus 48.75. That's going to give us 161.5 inches. Because we're finding area, it's going to be squared. So there's 161 of these little squares that cover this particular prism. Okay, 0.5 actually. Okay. Pyramid. Now for a pyramid, it's a square pyramid, so that makes our life much easier. So a square pyramid has a square at the bottom, and on the laterals, the sides, it has 4 faces and it has 4 triangles. 1, 2, 3, 4, and lucky for us, all the triangles are the same. So this square, it's a 6, and this is a 6. So to find the area of this square, it's just length times width, and that gives us, now right here, 36 centimeters squared. I'm not going to write the unit yet. And then for the triangle, our base of the triangle is this, right? Which is 6. And the height is 12. And it's going to be the same for all the other triangles. And the height of each triangle is also going to be 12. So triangle is base times height divided by 2. So it'd be 6 times 12 divided by 2, which is going to give us, I don't know, 36. Okay. Oh, look at that. Everything's 36. So the second triangle is also going to be 36. Third is also going to be 36. And the fourth is going to be 36. But we need to find the surface area, which is the area of all the faces. So we're going to add this, 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 and this. So 36 plus 36 plus 36 plus 36 plus 36. Or this faster way, 36 times, what is this, 5. And that's going to give us 180 centimeters squared. Okay. 6. Okay, so there is a window in the living room, and the window in the living room is this big. Okay, it's not. So it's 6.2 feet high. Okay, and the width is 4.6. And there's another window in the bedroom that is a little bit smaller, 3 times smaller, as a matter of fact. And we want to find the area of this bedroom, of the window of the bedroom, but we don't have any of the dimensions, but we do know that it's 3 times smaller. Okay, the area is 3 times smaller than the window in the living room. So let's find out what the area in the living room is, which is 4.6 times 6.2. That's going to give us 28.52 feet squared. And we know that this is 3 times smaller, so we're going to divide that by 3. Okay, so it's going to be 28.52 divided by 3. And divided by 3 is going to give us, a very ugly decimal, which you're going to round to the nearest hundredth, okay? And that's going to give us the area is 9.51 rounded to the nearest hundredth, okay? Feet to the second power, okay? And that's the answer, and that is the area of our window in the bedroom. It's actually quite big. Okay, and nothing. We're gonna go to the next question. Hang on a second. No, canceled. Our soccer game got canceled tomorrow because of the rain. Next one is a triangular pyramid. So you need to be able to imagine a triangular pyramid. So if you want to draw it, you can. Here's a triangular pyramid. A triangular pyramid has a base that's a triangle. And then you got go like this, and go like this. Alright, so that's a really ugly one, but you get the idea. We want to know the number of faces, so there's going to be 1 face, 2 face, and 3 that you're not seeing. Okay, that's on this side right here. So there's 3 faces. Vertices, you have 1, 2, 3, 4. Uh-oh. No, there's 4 faces. I'm sorry, 4 faces. Okay, because the triangle at the bottom is 1. This one is 2. Okay, so you know what? Let me see if I can import a triangular. So give me a second. Okay, so I got an image of a triangular, oops, pyramid. And I have no idea where that thing is. Here we go. No, here we don't go. No, close, close, and there we go. So, let's see if I can paste it. Can I paste it? No, I can't paste it. Okay. So, let's take a break again. Okay, I think I got it this time. So, no. Where's your triangle? Here is your triangular pyramid. Clear. So it has, as far as edges, let's, you can maybe start with that because the faces, edges, we have 1, 2, 3, 4, 5, and then the 6, the dotted line. So it has 6 edges. Vertices, it has 1, 2, 3, 4 vertices. And the faces, you got the triangle at the bottom, so that's 1. The triangle in the back here, made by this triangle, 2. The triangle here is 3, and this triangle over here is 4. So it has 4 faces. So we're looking for 4 vertices, 4 faces, 4 vertices, and 4 edges. So let's see if we can find something to that. And yeah, we do right here. See, 4 faces, 4 vertices, 6 edges. Does it have 6 edges? Yes, 6 edges. Okay. Which figure has 3 rectangles as faces? Oh my god. Okay, so has 3 rectangular pyramid. Well, rectangular pyramid, I build one. That's your base, and then you can bring that up. You can bring that up. You can bring that up, and you can bring that up. It's a pyramid. It has 1 rectangle. Everything else is a triangle, so that's gone. A cylinder. Let's not even talk about it. And again, let's do a prism, triangular prism. Something looks like this. Now this has rectangles. That's 1 this way. So imagine a tent or a roof of the house. So you have this side in the back, and this bottom rectangle, right? So definitely has to be a prism. That looks like it. Because a pyramid, a triangular pyramid, is going to look like this. And as you can tell, there's not a single rectangle there. So the only one is C. 9. Find the possible dimensions of a rectangular prism that has a volume. So you know the volume is going to be 180. Oops. So volume is big B times H. We're talking about rectangular prism. So volume equals big B's length and width times H. So we know that the volume is 180. So we need something length times width times height. It's going to give us 180. So find out. 8 times 20 is 160 times 1. That's not it. 45 times 2 is 90 times 1. No, that's not it. 90 times 1 is 1. Not sorry. It's 90 times 1 again is 90. So that's not right. 60 times 3 is 180 times 1 is 180. So, oops. It's this one. 60, 3, 1. And you notice that they equal each other. The left equals the right. Okay. A triangle, and we'll do this one. So for this one, where you're not asked for the area of a triangle, instead you're asking for one of its components, the base or the height, you want to use this. I think it's easier if you use that instead of this. Okay, I think it's more clear when you're using in this format. So let's substitute. That's half. Area is 22.14, so A is 22.14. Half stays the same. Base, I don't know, so I'll copy that. H, I do know, it's 5.4. So, one of the things I can do here, 22.14, I'm going to leave it alone for a second. And on this side, I can multiply a half. Remember, this is a half times base times 5.4. So I can multiply a half and 5.4. So let me leave the B here. And let's combine these two. So if you take the calculator and you multiply half times 5.4, okay, it would be 2.7. Okay. So now it makes this a little bit easier to look at. 22.14 equals b, the base, which is a number we don't know, times 2.7. How do we find b? Well, to find b, you're going to divide 22.14 divided by 2.7, right? So 22.14 divided by 2.7 gives us 8.2. So the base of our triangle is 8.2. You can always check, double check. So if you draw a triangle and the base is 8.2 and the height is what? 5.4. Will it give us an area of 22.14? So let's see if it works. So base times height divided by 2, right? Here's your triangle. 8.2 times 5.4 equals 44.28. Divide that by 2 and you get 22.14, which is exactly what you're supposed to get. Okay. Next one. This one. Next one, again. If you are able to count, I'm pretty sure this will be okay to do. So I don't suggest you count because it just takes too long and sometimes you can lose the count. So we're doing the perimeter. Well, let's measure the distances of each of the sides here. So this is 1, 2, 3, 4, 5. So I'm going to put a 5 over here. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4. No, that's still a 5, sorry. 1, 2, 3, 4, 5. 1, 2, 3. So this is 3. 1, 2, 3. This is also 3. 1, 2, 3, 4, 5, 6, 7, 8. That's an 8. 1, 2. That's a 2. Don't forget this one. That's a 1. This is 1, 2, 3, 4. This little thing is a 1. And this 2 is a 2. Wow, so there's a lot of numbers here. So 5 plus 5 plus 3 plus this 3 plus the 8 plus the 2 plus the 1 plus the 4 and then plus this 1 and plus the 2 plus the 1 plus the 2. Ugh. Alright, so 5 and 5 is 10 and 3 is 13, 16 plus 8 is 24, 25, 26, 27, 27 and 4 is 31, 32, 33, 34. So there are the units is 34 units squared. So this, all this that I just wrote would go under number 11. Okay. And the next, number 12, says find the area. So let's find the area. To find the area, I'm going to cut this. How would I cut this? I'm going to cut it like this. I'm going to call this A. I'm going to call this, I'm going to call this, okay, so that's not going to work. So I'm going to call this B. I'll call this very thin one C and D. So I cut it up into 4 pieces. So rectangle A looks like that. And rectangle A is 1, 2, 3, 4, 5 across. And how high is this? It's just 2. Rectangle B, a little bit bigger or thicker. Rectangle B is 1, 2, 3, 4, 5, 6 across, right? Going 6 this way. 1, 2, 3, 4, 5, 6, 7, 8. Did I just count this? Oh yeah, 6. This is 6, and then going up is 1, 2, 3. So it's a 6 and 3 rectangle. Excuse me. Rectangle C is a very thin one like this, and obviously the height is just 1, right? And going across is 1, 2, 3, 4, 5, 6, 7, 8, 9. It's 9 going across. Rectangle D. It's this one at the bottom. Rectangle D is 1, 2, 3, 4, 5, 6, 7, 8 across, and rectangle D is 1, 2 because it only goes up to here, so it's 1, 2. Alright, so I have the dimensions of my rectangles. This is a 5 times 2, which is 10. This is a 6 times 3, which is 18. It's 9 times 1, which is 9. And the last one is an 8 by 2, which gives you 16. So if I add all these circled numbers here, 10, 18, 9, and 16, I should get the total area of all of this particularly this composite figure. So let me just write this: 10, 18, 9, and 16. 89, 17, 23 goes to 53 units square. So you could have done it this way, or if you want to count this individually, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41, 42, 43, 44, 45, 46, 47, 48, 49, 50, 51, 52, 53. Yay! I'm right. So, 53 units squared, which is exactly what's inside. Okay? So that was 11 and 12. Next two. This one I think it's very simple. You do not have to draw the net. Okay? If you want to, you can. So you got, again, ways of doing this. You can do front. There's a front, there's always a back. You can do the sides. And I try to draw them as they look in the picture. This is the sides. And then the top and bottom. And, you can do it this way. Write your numbers, write the dimensions of each of the rectangles, and then add the areas of each of the rectangles, okay, that you found. But more efficient way, since we've discussed this, more efficient way of doing this would just be writing that the surface area is 2LW plus 2LH plus, I don't know, 2WH, okay? And basically it's 2 times front, 2 times the top, and 2 times the left, okay? Because left and right is the same, top and bottom is the same, and front and back is the same. So that's why you're multiplying by 2, because there's 2 of each. Okay, so now you get to substitute. So this is the height, this is the length, and this is the width. I have everything labeled. I substitute. And you get 2 times the length, which is 3.5, times the width, which is 2.5, plus 2 times the length again, which is 3.5, times the height, which in this case is 1.5, and finally 2 times the width, which is 2.5, and the height 1.5. And there it is. Here it is. Okay, it just becomes a matter of calculation. So first set, you get 2.5. or 2 times 3.5 or 3.5 times 2.5, and for that group you get 17.5. The second group here is 2 times 3.5 times 1.5 or 1.5, and you get 10.5. And the last set here, it's 2 times 2.5 times 2.5, and you get 12.5. So the surface area of that particular rectangular prism is the sum of all these numbers, 12.5 plus 10.5 plus 17.5 equals a total of 40.5 feet to the second power. Okay. And what are we doing? Oh, and then it's the volume. So the volume, I'm just going to do it here so I can have the picture on the screen. So volume is the area of the base times the height. In this case, the area of the base is this. Okay, so imagine this rectangle here, and if you put one rectangle on top of another rectangle on top of another, and you keep building it up, right, up this way, you get the height. So the height of this is 1.5, and the base is a rectangle, and to find the area of that rectangle, we multiply the length and the width, so it's 3.5 times 2.5. Okay, so 3.5 times 2.5, which you then multiply by 1.5. You actually don't even need the parentheses. So 3.5 times 2.5, that's the area of the base, and then we're going to multiply it by however high it is. It went 1.5, 1.5, and you get, and the instructions didn't say anything about rounding, so I'm going to leave the answer as it states in my calculator. 125 what is it, feet to the third power. And those of you who used it as a fraction, you probably got 13 1/8 feet cubed. It means the same thing. Okay, so again, if you watch this whole thing, oh yes, here is the word. It's going to be this, which was an awesome show. Hopefully you'll get to watch it when you grow up. Yeah, I'm gonna spell it out. There you go. Okay. And that's that. If you have questions, you have still the weekend to let me know if you want me to add to anything here. Okay.